Okay, 10.3 triangles. We should be on page 484, blank sheet of paper, ready to take notes. Okay, in example 1, we're finding an angle measure in a triangle. Okay, so they give us this figure. It has an angle measurement of 26 degrees, an angle measurement of 83 degrees, and I don't know the other one. I'm going to give you a minute to just write this down, including the equation, and then we'll work through it. All right, so I'm going to set this up as an equation. So I set it up, x plus 83 plus 26 equals 180. Why did I say that it equals 180? Where did I get that total from? Kathy?
A triangle equals 180 degrees.
Because all of the angles of a triangle always add up to 180 degrees. 100% of the time. Okay, they add up to 180 degrees. Now, does it matter the order that I add them in? What if I said 83 plus 26 plus x? Does that matter?
No.
Why?
It's because
Because as long as they add it to 180, it doesn't matter.
X is the number you're looking for.
What property? The commutative property of addition says I can add the numbers in any order. Okay? Little throwback there, all right, to our number properties. So I'm going to add 83 and 26 together first. So now I get x plus 109 equals 180. Now I'm going to solve for x. How do I solve for x?
Subtract 180.
No, don't subtract 180. Subtract 109 from 180, and x equals 71 degrees. All right, so basically what I'm doing is I'm adding the angles that I do know, and I'm subtracting them from 180. But all I'm doing is I'm setting it up in an equation, okay, with an unknown angle measure. Christian?
And x0 plus 8, why is that?
It's just the font that I used in this PowerPoint. So the 0 is actually the degree sign. That's a degree sign.
And that would be 83 plus 26.
Yeah, it's 83 degrees plus 26 degrees. It's just a different font. All right, does everybody have that written down? Okay, in example 2, we're finding the measure of an exterior angle. So go ahead and draw this figure, and then we'll go over how to find y. All right, so how do I find the value of y? Okay, here's how I set it up. I notice that the angles 35 degrees and y degrees, whatever it is, they're sitting on a straight line. So I know that they are supplementary angles. So 180 actually stands for the total measure of supplementary angles. I'm not even really dealing with the triangle here. I know that the angle measures within the triangle add up to 180, but with 35 degrees and y degrees, whatever it is, I'm dealing with supplementary angles. That should look very familiar to you because you've already learned that. So I set it up in an equation, y plus 35 equals 180, subtract 35 from both sides, and y equals 145 degrees. So to find the measure of an exterior angle, treat it as a supplementary angle. Only deal with the angle measure that is on the other side. Okay, so we're not worried about the other angle measures in the triangle. All right, now in example 3, we're classifying triangles based on their angles. And I thought that I corrected that. Sorry about that. We're classifying triangles based on their angles. Okay, based on their angles. So, go ahead and copy down these figures, and we'll go over them. All right, so in the first triangle, we have an acute triangle. The reason it's an acute triangle is because all of the angles are acute angles. All right, none of the angles are greater than 90 degrees. That's why we term it an acute triangle. With an obtuse triangle, it has one angle that is greater than 90 degrees. It has an obtuse angle, so that's why we call it an obtuse triangle. Now, is it possible for a triangle to have two obtuse angles?
Yes. No.
No, it's not. In order for them to connect on three sides, it's only going to have one obtuse angle. Now, in the last example, the right triangle, obviously it's going to have a right angle. So this should be a gimme on your quiz or your test if I put it on there. and you see that little box, it's a right triangle, okay, then that's going to be your answer. All right, it's a right triangle. Javon?
So obtuse is.
Yeah, it has an angle greater than 90, obtuse. Okay, and acute, they're all less than 90. All right, in example 4, now we're classifying triangles by their side lengths. Okay, so we have an equilateral triangle, a scalene triangle, and an isosceles triangle. Go ahead and copy down these triangles, and then we'll go over their definitions. All right, so an equilateral triangle has equal side lengths all the way around. So all 3 sides of this triangle will be the same measure. So here I have all 3 sides equaling 9 inches. With a scalene triangle, all 3 sides are different measures. There's no one side that is the same measure. And then with an isosceles triangle, at least two of the sides are the same measure, but one of the sides is not. So let me ask you this. Would an equilateral triangle also be an isosceles triangle?
No.
The answer is yes.
Yes.
Because the definition of an isosceles triangle is that it has at least 2 sides that are congruent. Well, does an equilateral triangle have at least 2 sides that are congruent?
Yeah.
Yes, it does. It has 3. It has more. So an equilateral triangle is also considered an isosceles triangle. All right, and if you understand that, that's everything you need to know for 10.3.